get started. Let's get in focus. Should be good. Let's continue where we left off before. And let me see. Just a moment, please. Okay. Let's go. Let's go. Let's go. Okay. All right. So let's take a look. I think I moved this thing a little bit ahead of where we were supposed to be. Oh, dynamic initialization. Initialization. I think this is where we left off. Oh yeah, dime init, and yeah, there it is. Okay. Let's go ahead and keep going over our reading here. Okay. What is this? We're ready to program 5.1. And now what we do is follow up with the explanation. So let's do that. Okay. Let's get on the explanations. From time to time, you may hear the fan blowing, but it's because it's a little hot in here, so I have the fan on. I apologize. Okay, that being said, oh, hold on. I gotta turn on the. Let me briefly pause this. All right, let's get back. Let's get back to business. I was a little distracted. Ooh, fixing some things. You're messing up here. And but let's get back to it. Okay, so we are, I think it's still chapter 3, and we're still discussing the variables. So we did the program in Nano, the small code I use as an example for dynamic initialization of C, which is a double. You can see right there on the screen. And well, now we're going to read some of the explanation. So here, 3 local variables A, B, and C are declared. The first 2, A and B, are initialized by constants. However, C is initialized dynamically to the length of the hypotenuse. Using the Pythagorean theorem. The program uses another of Java's built-in methods, square root, which is a member of the math class, to compute the square root of this argument. The key point here is that the initialization expression may use any element valid at the time of the initialization, including calls to methods, other variables, or literals. All right, the scope and lifetime of variables. So far, all of the variables used have been declared at the start of the main method. However, Java allows variables to be declared within any block. As explained in chapter 2, a block is begun with an opening curly brace and ended by closing a curly brace. A block defines a scope. Thus, each time you start a new block, you are creating a new scope. Okay, what page is this? Page 50, okay. Okay, a scope defines, or determines, let's see, what objects are visible to other parts of your program. It also determines, oh, I forgot, I don't have to use the mouse, I'm going to use the arrow. It also determines the lifetime of those objects. It is not uncommon to think in terms of 2 general categories of scopes, global and local. However, these traditional scopes do not fit well with Java's strict object-oriented model. While it is possible to create what amounts to being a global scope, It is by far the exception, not the rule. In Java, the two major scopes are those defined by a class and those defined by a method. Even this distinction is somewhat artificial. However, since the class, let's scroll up. Okay. Okay. However, since the class scope has several unique properties and attributes that do not apply to the scope defined by a method, this distinction makes some sense. Okay, because of the differences, a discussion of class scope and variables declared within it is deferred until chapter 6 when classes are described. For now, we will only examine the scopes defined by or within a method. The scope defined by a method begins with its opening curly brace. Let's move that up. Okay, right there on the top. However, if that method has parameters, they too are included within the method's scope. A method's scope ends with its closing curly brace. This block of code is called the method body. As a general rule, variables declared inside a scope are not visible, that is, accessible, to code that is defined outside that scope. Thus, when you declare a variable within a scope, you are localizing that variable and protecting it from unauthorized access and or modification. Indeed, the scope rules provide the foundation for encapsulation. A variable declared within a block is called a local variable. Excuse me. Oof. Going crazy. All right. So, you see, let's read that again. Thus, when you declare a variable within a scope, you're localizing that variable and protecting it from unauthorized access and or modification. Indeed, the scope rules provide the foundation for encapsulation. There we go. A variable declared within a block is called a local variable. Let's scroll up. Okay. Scopes can be nested. For example, each time you create a block of code, you are creating a new nested scope. When this occurs, the outer scope encloses the inner scope. This means that objects declared in the outer scope will be visible to code within the inner scope. However, the reverse is not true. Objects declared within the inner scope will not be visible outside of it. To understand the effect of nested scopes, consider the following program. Ooh, another program to write in Nano. Okay. All right, let's get back to Nano now. Yep. Okay, so we're going to write another program and we'll start here. Nano, and we're going to call it scope. Scope.java. Okay. Just because I like it, we're going to do the. Yep, what's happening? Nano. What the hell just happened? Oh. The heck just happened? Okay, so it was a little slow, but we're gonna work through it. Okay. So, I think that what I'm going to do is I'm going to create another scene so that I can have the book projected and also the another scene for the terminal. I couldn't think well. Quack, 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 quack. Anyway, yeah, so I'm going to do that. Well, for now, let's get back on the screen and write the code. So first a comment that is to declare what we're going to build right now. Demonstrate block scope. Okay, so class scope. I do my braces immediately. Okay, public, of course, static void main string arguments. Oh, excuse me. Immediately int x, which is known to all code within main, and then we're going to x initialize it equals 10, and then if x is equal to 10, is comparing the value, and now here we start another bracket, and we're going to make a comment, start new scope. We're starting a new scope with this bracket we just made. Okay, int y, no, it's worth 20. This variable is only known to this block. Okay. You know, I wonder if I could. Oh, I can. Oh, that is so awesome. Oh my God, that is so great. Because I wasn't using this. Let's go to end. Oh my God, beginning. Oh no. Oh my God, it has the same. I just realized it has the same shortcut. I gotta change that. Oh my God. Okay, so right here, I gotta change that. Okay, so here, that's what I meant to do. Oh, okay. So now we're going to do another comment. X and Y both known here, and then system, the out, the print line, x, x and y plus x plus space plus y. Okay. X equals y times 2. Okay. So if x, okay, and now we're going to then end right there. I think that's the whole program, I think. Oh no. This one says y equals 100. Error y not known here. Because y was declared within the scope of the method. And is alright, I think now we're good. Yeah, I think now we're good. Let's see. Yeah. Alright, I think we're good, and so now let's compile it. Errors, let's see. No. Very code. Java scope x and y 10 and 20, x is 40. There we go. Very nice. All right, so let me pause the video and we are going to continue in just a second. So I will be right back. I will be right back. Okay, so we're back. I was building some scenes which I think are completely necessary, and here they are. First, regular blocking scene, and this, then this one. Uh, I think I have two scenes assigned to the same thing. Oh my god, I think I do have two scenes assigned to the same thing. Oh my god, yeah. So, okay. I'll need to pause it again. Okay, so we're back. Okay, fix it. So now we have my main commentary screen. Then I also have the book by itself, so easier to read like that. And then I also have the command line so that we can just write over it. And of course, and then my other screen. So let's go and get this done. Ooh. Okay. Okay. Let me take a look at something here. Okay. All right. Finally. Okay, we can move on. Okay, cool beans. We can move on. Okay, so we were reading. We were reading. And let's see. Okay. Okay, let's see. Okay, so we were just reading on the explanation of this thing. Okay, we had done the output and we were looking at the explanation of it. So let's do that. Let's go over it. Okay, so as the comments indicate, the variable x is declared at the start of main scope and is accessible to all subsequent code within main. Within the if block, y is declared. Let's look at the code because I think it's going to help to look at the code right here. Okay, that's what they're talking about. That's what they're talking about. Okay, that's what they're talking about. Okay. So y was declared within the block of the if statement. As you can see, the if statement starts in the scope, and let's see. And it's right int y equals 20. So then you try to use it outside, and it says equals 100, but y was never declared outside of that scope, so the system doesn't know that y exists there. It only knows that it exists inside. That's what they're talking about. It's right there. See, y equals 20. int y20 known only to this block. Okay, and then they try to use it again to reassign to 100. Okay, that's what he's talking about. Okay, so let's see. Okay, let's see. Okay, let's see. Here we go. Okay, a block defines the scope. Y is only visible to other code within its block. That's what I was saying. Yeah. This is why outside of its block, the line y equals 100 is commented out. If you remove the leading comment symbol, a compile time error will occur because y is not visible outside of its block. Compile time is when the Java virtual machine, or the compiler, I should say, checks for the compiler checks for the proper syntax to then write the code as the Java language. I forget the name of it. Okay, so that's the thing. Okay, so I forget what you named. What's it called? I forget what you call the code that Java writes. Okay, but anyway, let's keep reading. Let's see. Within the if block, X can be used because code within a block, that is a nested scope, has access to variables declared by an enclosing scope. Okay. Within a block, variables can be declared at any point, but are hold on, sorry, I gotta check my. Here we go. Okay. Okay, within a block, variables can be declared at any point, but are valid only after they are declared. Thus, if you define a variable at the start of a method, it is available to all of the code within that method. Conversely, if you declare a variable at the end of a block, if you define a variable at the start of a method, it is available to all of the code within that method. Conversely, if you declare a variable at the end of a block, it is effectively useless because no code will have access to it. For example, this fragment is invalid because count cannot be used prior to its declaration. Let's see the example. This fragment is wrong. Count equals 100. Oops, cannot use count before it's declared because it is declared by int count semicolon statement. Okay, let's keep reading. Here's another important point to remember. Variables. Okay. Variables are created when their scope is entered and destroyed when their scope is left. Oof, so they don't stay in memory. This means that a variable will not hold this value once it has gone out of scope. Therefore, variables declared within a method will not hold their values before it calls to that method. That created this store with each call. That's amazing. Also, a variable declared within a block will lose its value when the block is left. Thus, the lifetime of a variable is confined to scope. If a variable declaration includes an initializer, then that variable will be reinitialized each time the block in which it is declared is entered. For example, wow. Consider the next program. Alright, so now we're going to create code called lifetime. So let's switch to our command line because we're going to get there now. Okay, let's see. Alright, we're going to use nano to do this, so nano life time. Seems to be frozen. Oh, I hate that. Oh my god, it was frozen. Java. Okay, so Nano is the edit text editor within the command line. Now we're going to write demonstrate lifetime of a variable. Class lifetime public static void main string. Okay, let's see what the rest of the code looks like. Okay. Okay, so I should put a background into this thing. For x equals 0, x as long as x is less than 3, x plus plus. Okay, and then open another int y equals -1. Okay, y is initialized each time block is entered. Okay, let me start marking so out that print line. Okay, and okay, so y is plus y is is always print -1. Okay, y equals 100. Y is now plus y okay, so let's see int equals x, and then there's a for loop, and let me do this. Let me pull a for loop on a new line. Okay, so now we know okay, let's see. All this code is inside the for loop, right? Okay, where is I'm missing a bracket here. I think I'm missing a bracket. Yeah, I think we're good now. It's probably gonna have a composite error because I feel like I'm missing, but I don't see it anywhere. Okay. Okay. Okay, I think we're good. So let's exit. Let's compile that. Okay, let's compile that. Oh. Oh, wait. Variable y, location, class file, error. Oh, the compile time, of course. No, there's no compile time because y is already initialized. Okay, system out. Y is. Oh, I think I used a capital Y. Okay, so nano ifetime.java. Here. I. There we go. That's what I meant to say. Okay. So again, let's compile. Okay, and then let's run. Caused by Java land, the class not found exception. Okay. Lighten class. It actually is there. If you look at the screen, okay, right underneath, you're gonna see the class right here. Sorry, right here. So it's right there. There must be an error here, something we're doing wrong. Okay, so let's switch again. Content final load. A second. Lighten that class. There it is. Oh, it's because of the dot. Okay, there we go. There you go. It was a dot. See, that was a strictly typed language. You have to be exact. There you go. Alright, so, well, it worked successful. And now I have to pause it for a moment so I can make some fixes. Alright, let's see. Let's go.